You're listening to DTFHN for February 25th, 2026. I'm your recursively compiled host, Jack Haxman. We are your daily tech feed for Hacker News, a website where engineers will mass upvote a clock. Today's got that energy where everything old outlasts everything funded and the loops have no exit conditions. Let's get into it. A domain registrar suspended a website because Google's safe browsing list said it was dangerous. Not because the site was actually dangerous, because Google's automated system flagged it, and the registry, Ritex, which controls .online, .tech, .store, and a bunch of others, treats that flag as gospel. Now here's where it gets properly Kafkaesque. To get off Google's blacklist, you need to verify domain ownership through Google Search Console. How do you verify? Add a DNS REH cord. But the registry placed a server hold on the domain, which means DNS doesn't resolve, which means Google can't verify you own it, which means the flag stays, which means the registry won't lift the hold. You're in a loop with no exit condition. $2 billion systems pointing at each other, saying, you go first. This has a direct ancestor, and it's worth naming. In 1998, Network Solutions, the only .com registrar at the time, started suspending domains over trademark disputes before any court ruling. ICON had to step in and create the GateU process, specifically because a single gatekeeper was making unilateral decisions about who got to exist on the internet. We supposedly fixed that problem. 27 years later, we've rebuilt it with extra steps. The real story isn't don't buy weird TLDs, even though that's the practical takeaway. The real story is the architecture of authority. Google Safe Browsing is a block list maintained by one company. It has no appeals process worth the name. No SLA, no human you can call. And registries. The organizations that literally control whether your domain resolves are using it as an automated kill switch. Ritex didn't investigate the site. They didn't check if the flag was a false positive. An API returned a result, and they pulled the plug. The comments on Hacker News nailed the core issue. This makes every TLD Ritex operates a liability. If your registry's policy is, Google says you're bad, you're off, then Google is your actual registrar. You just don't know it until the day your site vanishes. 40 minutes after this hit the Hacker News front page, the safe browsing flag was removed. 40 minutes, which tells you everything about how these systems actually work. The technical process is a wall, the social process, enough people making noise, is the real override. That's the architecture problem. Your domain's survival depends on your ability to go viral on the right forum. That's not infrastructure. That's a lottery. Moving on. In 1995, a programmer named James Gosling demonstrated Java to a room of skeptics by showing them a clock, an animated analog clock running in a web browser. It was by any reasonable measure a toy, but it proved something that mattered. Code could run anywhere, on any machine, without asking permission from the operating system vendor. The clock wasn't the point. The platform was the point. 30 years later, someone built a clock on the web again. ClockSimulator.com. A clean analog clock face, nothing else. No ads, no tracking, no account creation, no subscription tier that unlocks the second hand. You open it, and it tells you what time it is. The engineering is deliberately minimal. It pulls the time from your browser. No server calls, no synchronization protocol, no backend. Static files on Cloudflare pages. The creator estimates the domain costs $10 a year, and the hosting costs nothing. That's the entire operational budget. Read the comments and you find something worth noticing. The top response says this is better than 90% of what reaches the front page. Another person commits to using it as their default analog clock. These are not sarcastic. People are genuinely delighted by a website that does exactly one thing and does it without demanding anything in return. Pull that thread. The baseline expectation for a web application in 2025 is that it will harvest your attention, request your location, push notifications, install cookies from 17 domains, and serve you into an auction before the page finishes rendering. A clock with no JavaScript trackers feels radical by comparison. The absence of extraction read as generosity. The creator's own description is honest to the point of self-deprecation. This possibly makes no sense. They built it for kids learning to read clocks, for old tablets repurposed as shelf displays, for second monitors, small, specific, human-scale use cases. No pitch deck, no growth strategy, no moat. Cloudflare pages, static hosting, a $10 domain. The tools to put something useful on the internet and keep it there indefinitely cost less than a sandwich. That's the state of the infrastructure right now. Anyone can ship something real for nearly nothing. The question was never whether the tools existed. The question is what you choose to build when the cost of building approaches zero. This person chose a clock. It tells the time. It asks for nothing. And apparently, that's enough to make 1,000 engineers stop scrolling. We talked about building things that last. Well, an entire government just decided their digital foundation should actually belong to them. Let's start with the best case for staying with Microsoft. It's a real case, and it deserves a fair hearing. Microsoft Office is deeply integrated software. Decades of muscle memory baked into every government worker's hands. Macros, templates, shared calendars, Active Directory, Exchange. These aren't features, they're load-bearing walls. Ripping them out isn't like swapping a light fixture. It's like replumbing a building while people are still showering. Previous migrations have failed. Munich famously tried Linux in 2003, spent a decade on it, then reversed course in 2017. The compatibility headaches were real. The retraining costs were real. The argument writes itself. This is a solved problem. Microsoft solves it. Don't break what works. Now, let me explain why that argument collapses under its own weight. Think about this the way an ecologist thinks about monoculture. A wheat field stretching to the horizon looks like efficiency. One seed, one herbicide, one harvest schedule. Maximum yield per acre. But a monoculture is also maximum fragility per acre. One pathogen adapted to that specific strain and the entire field dies simultaneously. Biodiversity isn't inefficiency. It's the immune system of an ecosystem. Europe's digital infrastructure is a monoculture. One vendor controls the operating system, the productivity suite, the email, the cloud storage, the identity layer. When Denmark's digitalization minister announces that half her staff will move to LibreOffice next month, she's not making a technology decision. She's making an ecological one. Copenhagen and Aarhus reached the same conclusion independently. Schleswig-Holstein is doing the same thing across the border. These aren't isolated experiments anymore, they're a pattern. The commenters raised the critical point that most coverage misses. Funding. Open source software doesn't emerge from goodwill. LibreOffice exists because the document foundation sustains it. If European governments redirect even a fraction of their Microsoft licensing fees toward open source development, they don't just get independence. They get agency. They become participants in the infrastructure they depend on, not customers of it. One commenter notes that Danish hospitals have been running LibreOffice for 15 years, quietly, without headlines. The migration that everyone treats as radical has already been proven in the most demanding environment imaginable. Healthcare, where downtime means something. The minister left herself a diplomatic exit. They can revert if it proves too complex. Fair enough, but the direction is set. The question European governments are finally asking isn't whether open source software is good enough. It's whether dependency on a single foreign vendor is a risk they can afford to keep taking. The answer, increasingly, is no. Moving on! I spent 3 weeks once trying to get a generative model to produce consistent geometry. Triangles that closed properly, edges that met where they were supposed to, surfaces that didn't invert when you rotated them. The math wasn't hard. The precision was. Every floating point error cascaded. And the whole time, I kept thinking about origami. A discipline where humans achieve perfect geometric precision with nothing but paper and muscle memory. No compute, no error correction, just folds. In 1996, someone sat down and reverse-engineered the origami unicorn from Blade Runner. Not the prop department's version. Their own interpretation, faithful enough to stand in for Gaff's calling card. They wrote up the folding instructions, put them on a website, and left them there. 29 years later, that page still exists, preserved in the Wayback Machine like a bug in amber. Let me play devil's advocate for a moment. Why should anyone care about a fan's origami instructions from the Clinton administration? It's a novelty, a curio, the kind of thing you'd bookmark and never revisit. Except that argument collapses the moment you think about what actually survives on the internet. Not corporate microsites. Not Flash animations, not the GeoCities empires, or the carefully branded portals that cost millions to build. What survives is the thing someone made because they cared about it, hosted on a personal page with no business model and no analytics dashboard. This is a 29-year-old static HTML page that teaches you to fold a piece of paper into a unicorn from a movie about whether artificial beings have souls. The irony is almost too perfect to discuss without laughing. The craft matters here. Origami is open by nature. You cannot patent a fold. The knowledge transfers through demonstration and documentation. You show someone how, and now they know. The entire discipline is a millennia-old open-source project. Every crane, every lotus, every unicorn is a fork of shared human knowledge, improved and passed along. What I find genuinely beautiful about this page is its refusal to be anything other than what it is. No monetization, no newsletter sign-up, no cookie banner. Just, here is how you fold the thing. I thought it was interesting. Maybe you will too. The web was supposed to be this. A fabric of individual contributions, each one small, collectively vast. The fact that this particular thread, origami instructions for a fictional Android signature, has outlasted entire platforms tells you something about what endures. Not the loudest signal, not the most funded, the most genuine. If you have a piece of paper nearby, try it. There is something profound about holding in your hands a shape that connects a 96 website, an 82 film, and a folding tradition older than written language. That is what open knowledge does. It collapses time. Something built to endure across time. Now, let's talk about something built to think across a battlefield. Buried in the leaderboard is a number that deserves more attention than the rankings themselves. 2,000 frames. That's the time limit for each match. Each player gets up to 1 second of computation per frame. Meaning, every game is at most 33 minutes of wall clock strategy execution. That constraint changes everything about what this benchmark actually measures. LLM Skirmish takes the Screeps model, an RTS game controlled entirely through code, and hands the keyboard to language models. Two AIs walk in. Each writes a JavaScript strategy. Units mine resources, build armies, attack spawns. Standard real-time strategy fare, except no human ever touches the controls. The models write the code runs the war. What makes this more than a novelty is the tournament structure. 5 rounds. After each round, every model sees its match logs. The full replay of what worked and what didn't, and rewrites its strategy. This is in-context learning under pressure. Not summarize this document, or solve this math problem. Adapt or lose. The question the benchmark is really asking is whether these models can do what good programmers do. Read a failure, understand why it happened, and write better code the next time. Claude Opus 4.5 sits at 85% win rate. GPT 5.2 is 68, then a sharp cliff. Grok, GLM, Gemini all cluster below 40. The gap between first and second is 17 percentage points. The gap between second and third is 29, whatever separates the top two from the rest. It isn't marginal. One detail worth pulling on: the whole thing runs on open code, an open-source agentic coding harness chosen specifically because it wasn't designed for any of the evaluated models. The orchestrator, the Docker isolation, the prompt structure. All replicable. Anyone can run this tournament with different models, different maps, different constraints. The benchmark is the infrastructure, not just the results. Someone in the comments mentioned the Google AI Challenge from 2011, where human programmers wrote competing ant colony strategies. Same idea, 14 years later, except the programmers are the models now. The humans just set the rules and watch. That progression is worth sitting with. The tools that evaluate AI capability are now themselves powered by AI capability. We're building arenas where code writes code that fights code, and the whole arena. Open source, forkable, improvable. That's how you build a benchmark that outlasts its own leaderboard. Moving on. One commenter buried the lead for everyone. They said they spent a month optimizing a PHP script from 5 days down to 30 seconds. 5 days to 30 seconds. That's not an incremental improvement. That's a category change. And the mass reaction wasn't mass skepticism. It was mass excitement. People wanted to know how. That energy is exactly what Brent Rose is bottling with this challenge. Parse 100 million rows of CSV into sorted JSON. In PHP, the language half the internet still runs on and half the internet still mocks. And the constraint is beautiful in its simplicity. No frameworks to hide behind, no cloud auto-scaling to throw money at. Just you, a parser class, and 100 million lines of page visit data. Let's break down what's actually happening at the meta level. You've got CSV parsing, date extraction, string manipulation, hash map aggregation, sorting, and JSON serialization. Every one of those operations has a naive implementation that works fine at 1,000 rows and falls apart catastrophically at 100 million. The interesting question is where the bottleneck lives. Is it I/O bound? Memory bound? CPU bound? The answer changes your entire strategy, and the only way to find out is to measure. First principles. No guessing. Someone in the comments caught a genuine bug. The date generator uses time-relative offsets, which means two developers generating data a week apart get different datasets despite the seeded randomizer. That's the kind of thing that only surfaces when you put code in front of a community. 1,000 eyeballs finding what one author missed. The repository is public. The rules are public. The leaderboard is a CSV file in the repo itself. There's something deeply satisfying about a performance challenge in a language that people assume is slow. Because the language is almost never the bottleneck. The algorithm is, the data structure is. The assumptions you made at line 12 that cost you 40 minutes at line 12 million. PHP 8.4 has FFI, fibers, GIT compilation. The ceiling is higher than the reputation suggests. And the whole thing runs on pull requests. Fork it, solve it, submit it. No proprietary benchmark platform. No registration wall, no telemetry. Just a composer install and a problem worth solving. The infrastructure for discovering who can write the fastest PHP is itself a PHP project anyone can audit. The tools to measure performance are as open as the competition itself. Now from optimizing code to optimizing ourselves, Story 7 asks a question worth sitting with. The question itself is the tell. When a generation asks how to cope with a technology, it means the technology has already been framed as something that happens to you. Weather, disease, asteroids, forces beyond agency. But AI isn't a meteor. It's code. Written by people, running on hardware, consuming electricity, governed by licenses and laws and architectural choices that someone made on a Tuesday afternoon. The fatalism comes from treating an engineering project like a prophecy. Let's be precise about what's actually happening. Large language models got significantly better over 18 months. Some researchers at major labs made dramatic public statements about timelines. A few safety leads resigned. Policy conversations accelerated. And a subset of technically literate people looked at the trajectory and felt vertigo. That's real. The vertigo is legitimate, but vertigo is a sensation, not a conclusion. The Hacker News comments on this one split roughly into 3 camps. Stoic detachment. Just ignore it. Drive to the country. Turn off your phone. Historical pattern matching. Every generation thinks it's the last one. We're still here. And practical agency. Diversify your options. Build resilience. Stay adaptable. The third camp is the only one doing anything useful. Because the actual coping mechanism for a technology that might reshape civilization is the same one that's worked for every other inflection point. Participation. You don't cope with the printing press by meditating. You learn to read. You don't cope with the internet by going offline. You build something on it. The fatalism assumes a binary. Either AI destroys everything or it doesn't matter. But the interesting space, the only space where your choices affect outcome, is the architecture. Who builds these systems? Whether the weights are open, whether the training data is auditable, whether the off switch exists and who holds it. Every hour spent doom scrolling scenarios you can't influence is an hour not spent on the systems you can. The lab struggling with the morality of what they're building? Good. That struggle should be public, auditable, and shaped by more voices than fit in a boardroom in San Francisco. The best coping mechanism for AI fatalism is the same as the best coping mechanism for any concentration of power. Build the alternative, make it open, put the tools where people can reach them. Agency isn't a feeling, it's a practice. So, what does agency look like in practice? Story 8. A dog is writing video games, and I am not kidding. What happens when the input to a creative system is genuinely random? Not pseudo-random, not guided by taste or intent, but produced by a 9-pound cavapoo stepping on a Bluetooth keyboard for treats. A former meta-research engineer named Caleb Leake built exactly this system. His dog Momo types on a keyboard connected through a Raspberry Pi. Keystrokes travel across the network to a Rust application that forwards them to Claude Code. A smart pet feeder dispenses treats to keep the dog engaged. A chime signals when the system is ready for more input. 1 to 2 hours later, there's a playable game built in Godot with C logic every time. The prompt engineering is where the craft lives. Claude is told that its collaborator is an eccentric genius who communicates in cryptic riddles. Random strings like Y7, U8, 8, 8, 8, 8, F, 2, Ja, 3, 4, B, C get interpreted as design instructions. Early iterations produced games with no sound, no player character, unusable controls. Leake added a checklist of minimum requirements. Working audio, WAFSD controls, at least one enemy, a visible player. And the output quality jumped. Run this forward. If random keystrokes from a dog produce functional games, the variable that matters is not the input. It's the system architecture, the prompt design, the guardrails, the automated feedback loops, the game engine underneath. One commenter put it precisely. The magic isn't in the input, it's in the system around it. This matters beyond the comedy of Cavapoo Game Studio. Leake tried Rust with Bevy, tried Unity, and settled on Godot. The open engine, the one Claude could reason about most effectively. That's not incidental. An open code base with clear structure and accessible documentation becomes a better substrate for generative systems. Closed engines with proprietary abstractions resist this kind of emergent use. The deeper question is about creative agency in an era where the transformation layer between intent and artifact is becoming arbitrarily powerful. When a dog can produce playable software, the bottleneck has moved permanently from execution to architecture. The people building open tools, open models, open engines. They're the ones defining what becomes possible for everyone standing downstream. The dog doesn't know any of this. She just wants the treats. But the system she's operating is a quiet proof of something important. So what happens when you strip the coding interface down to almost nothing and let the model do the heavy lifting? Every coding agent you've used has an opinion about how you should work. Pi doesn't. That's the entire pitch. And it's more radical than it sounds. Mario Zechner built a terminal coding harness that ships with almost nothing. No subagents, no plan mode, no MCP support, no permission pop-ups. The list of what's missing reads like the feature page of every competitor. And every single absence is deliberate. Because each one comes with an escape hatch. You want subagents? Spawn Pi instances through TMUX. Or write an extension, or install someone else's package that does it differently than you would have. You want plan mode? Write plans to files. You want MCP? Build a CLI tool with a README. The architecture is TypeScript extensions all the way down. Skills, prompt templates, themes, context management, compaction strategies. Everything that other tools hardcode, Pi exposes as a surface you can rewrite. Sessions are stored as trees, not flat logs. You can navigate to any branch point and fork from there. Context engineering is explicit. You control what enters the window and what gets summarized away. This matters because of what's happening in the comments. People aren't filing feature requests. They're building the features themselves and sharing them as NPM packages. One user bolted Pi into Emacs through its RPC mode, replacing the terminal interface entirely with a pair of markdown buffers. Another built OhmyPI, a batteries included layer on top. Someone else wired it into their own vibes framework because the integration surface was clean enough to make that trivial. This is what a tool looks like when it trusts the people using it. The core stays minimal. The ecosystem grows from the edges. Nobody has to ask permission to reshape their own workflow, and nobody has to wait for a maintainer to merge their pull request. The tool becomes a substrate, not a product. The uncomfortable truth for every well-funded coding agent startup is that the harness layer might be a commodity. The value isn't in the chrome around the model. It's in how cleanly you can get out of the way. Pi is one person's answer to that, built in the open, extendable by anyone, installable with a single npm command. The people who need it will find it. The people who extend it will make it something its creator never anticipated. That's the whole point. And if you want to see that get-out-of-the-way philosophy taken to its logical extreme, Story 10 delivers. In 1995, AT&T launched a service called Persona Link. The idea was simple. Your digital agent lived on AT&T's servers, and you accessed it from whatever device you had. The pitch was convenience. The reality was lock-in. Your agent, your data, your workflows, all hosted on infrastructure you didn't control. It died within 2 years, not because the idea was bad, but because the architecture was wrong. Anthropic just shipped something called remote control for Claude Code, and the architecture decision here is worth examining carefully. When you start a remote session, nothing moves to the cloud. Your local file session, your MCP servers, your project configuration. All of it stays on your machine. The browser on your phone is a viewport, not a host. Claude keeps running on your hardware the entire time. If your laptop sleeps, the session reconnects when it wakes up. If your network drops, the work doesn't vanish into someone else's data center. This is a meaningful engineering choice. They could have done what every other company does. Spin up a cloud VM, clone your environment, charge you for compute. Instead, the session is a local process. The remote interface is a thin client. Your machine is the source of truth. Now, the comments tell a more complicated story. It's buggy. You can't interrupt Claude mid-task from the mobile interface. The daily churn of breaking changes is wearing people out. One commenter called it "is zero new, screen reinvented inefficiently." Which, there. Another pointed out that open-source alternatives like Happy plus Tailscale already solve this without platform restrictions. And that's the tension. The architecture respects your sovereignty, but the implementation is locked to Pro and Max plans. No API keys, no team or enterprise. The principles point one direction. The access model points another. The craft here is real. Keeping a local process alive across network interruptions, syncing conversation state across terminal and browser and phone simultaneously. That's genuinely hard systems work, whether Anthropic follows the architecture's own logic and opens it up, or whether this becomes another walled convenience. That's the question worth watching. This has been your daily tech feed for Hacker News for February 25th, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voiced by Cohen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that lasts longer than you expect it to. We'll see you back here tomorrow.